Hello, this is Denton Yoder, instructor for BSE-2304, the Biological Systems Engineering CAD class. Today's class is about Lisp, L-I-S-P. I often call it lost in silly parentheses. It's a 1960s artificial intelligence language that's built into AutoCAD as a macro programming language. It is extremely powerful at especially running calculations or typing things on the keyboard for you. Excuse me. We saw last lesson that we can make scripts that use a program to put stuff in a file and make a script of data that we can import into AutoCAD. Well, this is more interactive. It allows you to ask questions of the user and do calculations and draw things on the screen. It also lets you make little simple macros to change the way the program functions, to add new commands. A couple of them we're going to look at. First off, just to get into Lisp, if you see a parenthesis on your command line, that's Lisp. I'm typing in parenthesis times 2.75 pi. And it says, oh, 8.63938. I can actually expand that. There's a function, real to string, and I'm going to times 2.75 pi. And I'm going to say, give me a decimal answer 12 places. And, oh, it'll give me more. So it is more accurate than what you see. It's just rounding for the default display settings. Okay. Commands you might want to use. Let's say I have some data on the screen. I'm going to just draw a couple rectangles. And with my wheel mouse, I can just double-click the wheel to get a zoom extents, roll the wheel back one, and I'm in a nice viewing place. But if you didn't have a wheel mouse, if you were stuck with a laptop and no mouse, well, what could I do? Well, I can make a little one-liner. Define a function, command ZA with no parameters to do the command zoom extents. And then as soon as you're done, do a zoom 0.9x. Close the command, close the function. I just made a command called ZA. If I type it, it does a zoom extents and then out a little bit. I think that's exactly what I wanted. Okay, interesting. Yeah, you can make commands to do what you want. It's not quite showing up all because I don't have it full screen. There we go. So that was a zoom at ZA for zoom all. So that'll kind of help me if I don't have a mouse. Okay, a zoom out would be another one. Define a function, command ZO, no parameters, just to do the command zoom 0.5x. Close the command, close the function, ZO, enter to repeat it, enter to repeat it, enter to repeat it, ZA to go back full screen. So you can make the commands to do the things you want. Another thing I want to note is just another function in Lisp called CV unit. So if I want to CV unit, I can convert units between different things. So an example of that is I want to take 10.5 E6, which would be 10.5 million. And I want to convert it from gallons to acre feet. Close parenthesis. And it says, okay, well, 10.5 million gallons would cover 32.2233 acres 1 foot deep. So an acre foot is how much 1 foot deep over an entire acre would be. So 10.5 million gallons would give me 32 acres a foot deep. That's pretty cool. Let's see. I got an idea. What's a big number of miles? Let's say 1 billion miles. How about convert unit 1E9 miles to light years. Oops, I missed my quote, close parenthesis. Okay, so 1,000,000,000 miles, 0.00017 light years. You may ask, well, what units does AutoCAD support if it's got light years and acre feet and miles in it? There's a file, it was probably right beside the acad.pgp file. It's called acad.unt. It's the units file, and it tells AutoCAD all the units that it knows to deal with. So if you wanted to, you could CV unit 1.0. It's good not to use an integer. Hogsheads to gallons. So I'm going to say that it's quite thorough in its definition of units. Okay, jumping into another angle. The ZA and the ZO commands that I made are only available to me in this drawing right now. If I close this drawing, those commands are gone. So really we want to put commands in a file where they can be loaded again all the time. So to do that, let me just show you how I do it. I make a folder on my hard drive. So if I go to my C drive, I have a VT CAD tools. And that's where I put all my Lisp routines that I write. I also have an ACAD doc file. Well, I think I have an ACAD doc. There it is. I have an ACAD doc file in my folder, and it has a startup job, which this is going to run automatically whenever I open up a drawing. And so I could put my functions in here. Define a function, C:, zoom all, to be the command zoom extents zoom 0.9x, close the command, close the function, and copy that, paste, zoom out is going to be a zoom 0.5x, save that. So this will only work though if AutoCAD knows how to find it. So I have to tell AutoCAD where I put my programs. I also put blocks in here so that when I insert things, it can find them automatically. Okay, so if on the command line, if you right-click, there's an options, and there's a file tab with a support file search path. If you scroll to the bottom, we don't want to change what's there. We want to add, so you have a new line, then browse, and pick the folder where you're putting things. For me is CAD tools. Now, if I close this drawing and start up a new drawing, the computer says, hey dude, I'm seeing this ACAD doc thing, what do you want to do? And I'm going to say always load. And so now it knows about that ACAD doc file. So if I have a couple objects on the screen and I type in ZA, it works. ZO, it works. Because they're loaded automatically when I load my drawing. Okay, last thing I'm going to talk about, Lisp. I'm going to write a big Lisp file. It's, well, not even really a page. But to explain why, I'm going to generate a bolt hole. And so in my example, I'm going to draw a circle And I'm going to draw it by diameter 1. So that was a circle with a diameter 1. Well, maybe it's on the wrong layer, because it really should have a layer to put it on. I really should probably make a layer for that to go on, but I didn't. But I'll do it in the program. Okay, so I ought to have a layer for the bolt hole. I want to draw another circle, and I want to make sure I have a snap to go to the center and get them lined up. And this one's diameter is going to be 2 times the first one. And then I'm going to put a polygon, 6-sided, at the center of that. And you measure polygons, or nuts, I'm going to call this, flat to flat for the wrench size. And that would be a circumscribed polygon. And I want to use 1.5 for the diameter, but this is asking radius. So I'm going to do a 0.75 to get the nut in there right. And that is what I'm calling a bolt hole. Now, to draw a bolt hole, it was fairly easy. It was drawing 2 circles and a 6-sided polygon. And I made all the calculations proportional. You got one hole in the middle, you got another hole that's twice the size, and a nut that's 1.5 times the size. So it's kind of calculated. And they're all going the same place. Really, there's only 2 things I need to know, I need to ask to draw this, and that is, what size should the hole be, and where do you want to put it? Those are really the only 2 things I need to know. Well, we have a programming environment called Visual Lisp, VLISP. Whoops, there's a bolt hole already there. Kill that. Okay. Visual Lisp, VLisp, or VLIDE, either one will bring you into it. Visual Lisp, Integrated Development Environment. Inside here is an editor where we can do code. So I'm going to make code. I'm going to save it to my CAD Tools folder, and I'm going to name it bolthole.lisp. And yes, I'm overwriting the one I had a minute ago, and we're going to do a new one from scratch. Okay, the thing I'm going to try to get you to do is to do this kind of modularly so that you can test it as you go, because you don't want to type the whole thing in and then it not work and then you have no clue why it doesn't work. You want to do little bits at a time and make sure it keeps working the whole time. Okay, to start off, the format for the file is going to be define a function, command bolt hole with no parameters, and then at the bottom you close parenthesis, and that's the bolt hole. Comments, I'm going to tab in and put a semicolon and type a comment. Ask them the size. Okay. What I want to do is set Q, which stores a variable, diameter 1, D1, and I'm going to get dist. It's a keyword. There's a get real for getting a real number, but I like get dist because it lets the, I almost said patient, it lets the CAD operator choose on a point on the screen with the cursor if you use get dist. /n is a new line where it gives you a blank line, and it says, what is the whole diameter, dude? Close quotes, close paren, close paren. Okay. What else do we need to know? We need to know where you want to put it. Set quantity, 0.1, get point, and yeah, it does help if you know what the commands are. Where does it go, dude? Close get point, close set Q. Now might be a good time to test it. I'm going to save my document, go back to CAD, and type in load bolt hole. And it says, hey, I don't know about this. You sure you want to load it? Yes. I'm going to say yes, load it. Bolt hole. When I type that in, it says, hey, what's the hole diameter? I'm going to say 1. It says, where's it go, dude? I'm going to pick a spot. The program's over. But it's working. So I'm going to move on. What do we want to do now that you've done this is we want to calculate the other diameters. Set Q diameter 2 to be multiply diameter 1 by 2.0. Set Q diameter 3 to multiply diameter 1 by 1.75. No, 1.5. And then we want to draw a circle. So we're going to command circle. And circle is going to say, where do you want to put it? And I'm going to say, put it at 0.1. It's going to say, what's the radius? And I'm going to say, oh no, switch to diameter mode. And then it's going to say, well, what diameter? And I'm going to say, well, use that diameter 1. And close quotes. Command circle, same point, diameter D2. Now's a good time to test it again. Save. Go back to my screen, up arrow to get back to the load, and it says load, and it responded command bolt hole. So I'm going to type in bolt hole. This is, what's the diameter, dude? 0.5. Where's it go? Oh, right here. Bam, circle, circle. Hey, code's still working. I'm happy. Okay, next one's a little harder. Command polygon. I probably should have written it down, but what does it ask first? I believe the number of sides, so I'm going to put 6. I'm putting in a real number, or a number, so instead of text, so I don't have to quote it. And it wants to know where's the center. It's at 0.1. And now it's going to say, is this inscribed or circumscribed? And I'm going to say, oh, it's circumscribed. And it says, okay, what's the radius? Oh, crap, I know the diameter. Oh, I'm in a programming language. Divide diameter 3 by 2.0. Okay. Done with that polygon. Save. Test my program. Still loads. Bolt hole. Diameter 0.5. Where's it go? There. Sweet. Still working. Now, let's throw a wild card in. Once you drew one, we could draw another one. All we need is a new point to put it at. Okay, so what I'm going to do is right above the P1, well, right after the P1 actually, I'm going to add while not equal 0.1 to nothing prog n. Basically, I defined a loop. And I said, and I'm going to come down here, close the prog n, close the while. So the while is what the loop is. It says while not equal 0.1 to nothing, which means while you did not pick nothing, or while you picked something, repeat this loop. We need to put something inside here to help us get out of the loop, which is going to be this same exact line again. Set point and point 1, get point, and instead of where's it go, dude, I'm going to say where else. So I'm getting a point. I'm saying while this point is valid, do this, and at the end of it, get another point. And if they get a point, it'll loop and do it again. And if they get a point, it'll loop and do it again. If they don't get a point, it'll kick out. So save that. Go back and test. Load bolt hole. Bolt hole. 0.5. Here, 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 here. Sweet. Hit enter. Kicks out. Sweet. Now I want another loop. So I'm going to, after the distance that you put diameter you put in, I'm going to do another while. This time I'm going to say not equal D1 to nothing. Prog in. Now I'm going to tab everything in further. And close this prog in and close this while. And I need a line to keep it from looping infinitely. I'm going to grab that distance 1 line and put it in here. Set distance 1, get distance. Another diameter? Question mark? Or maybe next diameter? Whatever you want to tell them. Save this. Go back. Up arrow. It loaded. Bolt hole. What's the diameter, dude? 0.5. Where's it go? Here, here, here. Enter to kick out. It says, oh, next diameter? How about 0.25? Here, 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 here. Enter. How about an inch? Here, here. Enter. One more enter. Kicked out. Sweet. We just made a cool bolt hole program, and it's really hardly a paragraph long. It's asking a diameter. It's looping on everything inside it with that diameter. It's asking where you want to put it, and it's looping on everything inside that, and it's drawing the circles and the polygon. All right, that's the end for this class. Have a good one. Bye-bye.